Hey everyone, thanks for joining us for today's webinar. We're going to get started in just about 1 minute. We'll be talking to you real soon. All right, hello everyone. Thanks for joining us for today's webinar about integrating CloudBees CodeShip with Appranix for continuous app resilience. Just a few things that we know up top. We are recording, so if you need to leave early or perhaps you have a colleague who's unable to join, they will be able to view this later. 2, you can ask questions. We will have time at the end for questions, so as soon as you think of one, please put it right into the question panel. Even if you think maybe we'll answer it partway through, it always helps to know what it is that you're looking to know more about. This is part of our CloudBees CodeShip Innovator program. So what that is we like to do these presentations with companies that we really feel value and really believe in their product and their culture as a company. And so I'm very excited to be doing another one of these. It's always great to hear from these CloudBees innovators. Before I take up too much more of your time, I do want to get more right into the presentation. So I'd like to introduce our presenter for today, CEO and founder of Appranix, Govind. Govind, take it away.
Thank you, Max. Really appreciate the time. Hello, everyone. Thank you for joining today. I know everyone would be busy doing something or the other, and we'll make it worthwhile to dial into this webinar. So we are going to introduce a great subject, if you will. You know, everyone knows continuous integration. You know, you have been using CodeShip, you have been using CloudBees and other products in the market. And slowly continuous delivery is getting accepted as one of the mechanisms for delivering applications faster in smaller pieces across various infrastructures. You know, be it VMs, the traditional mechanism, or using containers, now using serverless, and maybe newer mechanisms are a combination of all of these together. But one of the pieces that's kind of missing is that, you know, there is this production cliff, if you will, you know, when you deliver continuously. What happens afterwards? You know, what if something goes wrong? So that's the part that we would address, and we'll go deeper in as part of the continuous resilience approach, as well as a mechanism with which you can be confident in terms of taking the delivery to the next level. So what we are seeing today in the market, and you know, today's market is moving much faster than before. The applications that are being lifted and shifted is a category of applications that are moving to the cloud platforms, be it AWS, Azure, or Google, and they are being set up with DevOps as the default operations model. You know, anything to do with day 2 operations is all going through the DevOps mechanism, because it's a predictable, again, a continuous delivery across that infrastructure as well. A second set of applications, the modern applications that are being created, are some of the older applications that are getting modernized, are being built using containers. And those containers are being run on Kubernetes. And those Kubernetes-based applications are getting delivered, again, using the proven continuous integrations that's taken for granted. Of course, you are facing some challenges, and that's where CodeShip comes in. Great. And then continuous delivery part using you know, either open source tools or a combination of open source and service mechanisms in the backend. So in these 2 models, the new applications that are being built need to be very clear in terms of what they are getting from an operation perspective. But when I dig deeper, ask tougher questions with customers, particularly the customers that are running business critical applications that are that cannot be taken down for any reason. It could be even a cloud failure and so on. It's disruptions are the number one enemy against application service level objectives, SLOs. And these disruptions could come from many different ways. And we'll go into every one of the categories where the disruptions occur. But if you think about just availability numbers wise, it's actually scary. Many of the folks maybe on the call everywhere, they may not even think in terms of, what is this 99.95 perspective? What is it? Once in a while, we may look at the table and I say, oh, well, the maximum downtime could be just 22 minutes. But the thing is, you can only be done about 22 minutes per month if you are operating 99.95. I mean, that is pretty scary, if you will. Right? Even a single application could take much longer to recover, combining all the operations as well as the development and delivery and so on. So the problem here is that I call it is clearly disruptions are the number one enemy, right? And then what are the disruptions? That could be many of them. There are different types of disruptions, and there may be many that we might have not documented all of that. But here, a single deployment could bring down the entire application. I don't know if you have faced that problem in your environment or not. It could be a very simple, innocent deployment that might have been made by a nice guy, a great developer, but at the end of Friday, he made the deployment, right? So that deployment created a chain reaction across, different parts of the service that entire application is down. So that is one type of mechanism. Individual cloud infrastructure failures. So if you think about cloud infrastructure as a whole, the infrastructure as a service provided by AWS, they have been increasing their resiliency pretty much from the beginning of 2008 onwards, right? There's a huge difference between what used to happen before and now. Individual services are great. So if you took, EC2 infrastructure service or GKE service, those operate at a pretty high resilience level. Of course, you have to read the fine print. But when you combine all these services together, you are actually creating a distributed application or a larger application. Then what happens to your application if one of those services comes down? Because the service levels for those different services are different. Again, different from service provider to service provider. That is the second type of failure. Third, I don't have to even educate anymore. Ransomware attacks are happening every week. A couple of weeks ago, there was an aluminum provider out of Europe that was affected in their US operations. And if you subscribe to one of these RSS feeds with respect to ransomware attacks, you would see time and again all these attacks are happening all over the place, and they are increasing, and they're unpredictable as well. So applications could come down any point in time, unpredictable, even though it's rare. The question would be how to actually get the applications back. Now, how do you really predict and at least be prepared for these disruptions? One way to do this is, the older way is do a DR test. Great, if you have all the infrastructure and everything is set up in a meaningful way, you could potentially do a DR test. If you have outsourced the DR activity to, let's say, SunGuard or IBM Resiliency Services, it becomes a project because you'll have to now sync up with your disaster recovery team, because the IP addresses may not even replicate to the recovery site, and then DNS collision, all those problems you'll have to take into account. The newer mechanism is that if you're deploying again and again to production environments completely, then you could do chaos engineering. Basically just disrupt the application in a predictable fashion using your own mechanisms and see if the application can actually withstand the disruptions. So even those areas, you'll have to really think about I know, whether the application is going to come down or not. How do you know? Even trying to do that, it becomes complex. AWS, like larger providers, they have created a pretty big white paper. To be specific, is about 78 pages long or something like that. Number of pages keeps on increasing, and they have dedicated 5 pages long DR checklist if you're running business critical applications on AWS, as an example. I'm sure similar white papers exist in other cloud service providers as well. So it's complex in its own area. Again, the disruption is real, even if you wanted to do testing. And SOX and SOC compliance. If you're operating a SaaS application and it's supposed to operate 24/7, then you'll have to most likely go for an SOC certificate. And these organizations demand a proof that you can actually recover the applications in the event of a failure, right? I'm talking about applications in the sense the entire application stack, not necessarily just a bunch of virtual machines and so on. SOX compliance, I think for those of you who have been with the operations side for a longer time, SOX compliance is another mandate from the government to make sure that you can actually recover your, let's say, business critical or financial applications. And finally, but not the least, clouds do fail. Like 3 weeks ago, Google, US East Coast, entered into some kind of a long disruptions because of networking issues and so on. A lot of well-known brands got affected. In those situations, you could think, can I switch to another cloud, at least temporarily, so that I can borrow some time to prevent the reputation damage to begin with, and also losing business is a big deal. At least you could borrow some time. This, I thought, this particular use case, I thought is a unique one that will come in pretty late in the market, but recently, quite recently, one of the well-known brands asked for this, and I am running our applications on GKE. Can I go to AKS as a failover into another cloud, because clouds do fail. So there are so many types of disruptions. If you have any of your experiences, we would love to hear from you in terms of what type of disruptions you went through. And if you have any additional points to add, we would love to kind of add that as well. And if you have any of those, please add that to text. Max will be able to coordinate. And Max, any other thoughts in terms of asking the audience to include their suggestions and thoughts?
Nope. You can, if you'd like to add something to the conversation, please feel free to put it right into that question panel, and we can take a look later on. Thanks.
Great. So the bigger question here is that how to decrease this enemy number one, disruptions, by 50 to 300%. That's a bold statement here, 50 to 300, but that is not inaccurate, if you will. So if you reduce the disruptions from 99.9% to 99.9%, then you are looking at a huge difference at 300%. From second layer to third one could be your platinum application or a gold application in terms of RPO and RTO wise. You are looking at a 15%. And the problem is not just a situation that arises once in a while. And so again, the disruptions happen for multiple reasons, including a single deployment. And we are not alone. Gartner has been noticing an increased set of inquiries coming in for cloud resilience since 2016 at 20% plus rate. So they are educating the enterprises. They are educating the organizations that are moving to the cloud, and a lot of them, even the SaaS, completely created, cloud-born, cloud-native application developers and SREs. They have not really thought through the entire aspect of the disruptions. Where could the disruption come from, and how can they really decrease those disruptions so that their SLOs are intact? So that is the part. We are going to help in terms of identifying those areas, and obviously you have to get an idea of how you could quickly reduce those disruptions, even if they occurred. How could you really recover from those? This is where our integration with CodeShip comes into kind of really handy, and CodeShip has been doing very well. Hey, Joe, if you have a few more points to add into CodeShip, I would love to have them.
Yeah, absolutely. So just want to give a quick plug for CodeShip. CodeShip is a SaaS-based CI/CD tool. So we handle all the backend infrastructure for you so that you can just be focused on running your continuous integration suites and doing continuous delivery. We have two products, Basic and Pro. Basic aims to be a simple and turnkey solution. It's great for small and simple, straightforward projects. And then we also have Pro, which is built around Docker and gives a lot more power and customization for your overall CI/CD pipelines. The demo that we'll do a little bit later will have the Pro interface in there a little bit. And CodeShip accounts are free to get started. Each account provides 100 free builds a month, so it's a great way to try the products out. You can try out, even just side projects or hobby projects are a great way to just test things out and get started. And we can also post a link into the chat if you're interested in signing up.
Great. All right, so CodeShip is, it's very easy to get started, and you don't have to really think about managing and maintaining your own CI service. Depending on the number of builds that you throw, you will have to manage that infrastructure. CodeShip actually takes care of all of that. It automatically scales in the backend, so you could simply focus on your application and your set of services. Now, disruptions can happen anywhere, like I mentioned. What if we gave you a simple and powerful undo command for your SREs and DevOps, or to you, maybe you are the SRE and DevOps folks in the line. And with a single line of DevOps pipeline code, right, you could potentially reduce the disruption by 50 to 300%, right? So the way to do it is that you have your CI setup, continuously building and releasing using CD capabilities of CodeShip as an example. And we could simply take to the next level called continuous resilience, CR, where we would make the copies of your production environment with that single line of code. And then using that, you could do rollback or recovery or failover in the same cloud or an alternative cloud. Just think about that situation, right? With this single line of code, you say AX stands for Appranix, protect application protection service, APS, protect your assembly. Assembly is a concept that combines a bunch of services together. As I mentioned, your applications are not 2-tier or 3-tier or 5-tier applications anymore. They are spread across multiple services, multiple infrastructure services, and microservices that are built maybe on the containers completely. So those services put together, you could call that an assembly. You can change the assembly configurations and so on, very flexible mechanism. And then you pretty much integrate that into your DevOps pipeline, and we simply take care of the rest. That way, you have the confidence that if any of those disruptions happen, as I mentioned before, you have the confidence to do an undo of that activity. And by the way, we use it all day long, using our own pipelines. We built our service so that we could use it. And many of the other customers also do the same. Praga is a great example. They operate on Google completely. It's an edtech company for enterprise, edtech company for universities, and thousands of students sign into those university portals to interact with Praga system. So the requirements are very, very stringent in terms of being able to run that application completely on Google platform. And they follow all the standard DevOps practices to release application updates. They have multiple environments. Even some of the larger universities get their own tenant, if you will, in a separate instance of Praga. So multiple environments, but mostly a larger SaaS instance serves many universities in the backend. And Appranix helps them in terms of managing that SLO, in terms of providing that capability to go back in time so that they can be confident in terms of releasing their application updates or taking that next step in terms of doing a DR test, or even in the case of failure, you can very easily recover. That gives them so much confidence in terms of rolling out the next updates. Right. Next one is a huge customer of ours, Live Nation. It's a 10 billion revenue entity, so it's a Fortune 100. And they pretty much gave us a lot of requirements in terms of what is required from their point of view when they operated on AWS. And they have hundreds and 120 applications to be specific, and they are growing their application base completely on AWS. They have moved to AWS for the longest time, and they have been highlighted at AWS Read in Invent in terms of how they are able to utilize AWS. But the missing piece is clearly the ability to handle the disruptions. And most of the time, the applications run okay because they are kind of a combination of the legacy as well as the modern application part. And if something happens, they have that button to click, a single click to go back and recover the entire application environment. So that's the capability, and they've been using it for a long time. So you could say, all right, Appranix guys, fine and dandy. This is not a big deal. I could potentially create it, right? There are smart people out there. There's very smart people. I have met some of them. They can code it up. One of the SRE leads told me that it's amazing that cloud infrastructure is accessible as a JavaScript object. Can you imagine? That's so much power given to the developers. That's amazing. And that's real. That's how the new applications are getting created. And that's welcome as well, because we need to move away from the infrastructure as much as possible. Now, you could also be a lot more flexible, by packaging them in the containers, because you can wrap all the dependencies. And I used to be a developer, so I could feel the pain at the time that, when you include a libc, that version may not work really well in a production environment with another libc 1.5.7, right? So that kind of incompatibility, I think, will go away completely once all the applications move and get packaged in containers. So eventually you are running your application environments with multiple services put together. Now, the idea is that disruptions happen, that's real, right? It's not a question of not happening, it's happening every day. Smaller areas and larger areas, and entire application could come down as well. If that's the case, the biggest question is how to really decrease those disruptions. You could start with cloud automation. You could manage the snapshot lifecycle of your data infrastructure. You'll have to, there's no point in managing the application disruptions without really managing the data component of your application, data infrastructure. That's complex enough. And then you will have to think about infrastructure code versioning, because just like your code managed and checked into GitHub and versioned, all of that, and then created with a pipeline, people create infrastructure as code. That's a predictable way to do it. And then, sometimes the newer things get introduced that, seem kind of great, but at the end of the day, they actually introduce newer problems. And then comes the state management of the infrastructure as code. And then you will have to manage the Kubernetes infrastructure. There are great services that are becoming available, so you don't have to really worry about the Kubernetes master and so on, but the infrastructure to manage your application, which is basically the worker nodes and all other things combined there. It's your problem, your application developer's problem, or the SRE problem, to be specific. With all of that, we ask the question, can you really guarantee the application resilience, right? And, there's so many moving parts, not only that higher level conceptual to-do list of things, but also the dynamism of the cloud infrastructure itself. Forget about in the parts moving around and then they get killed and recreated in a different node. That's all fine and dandy, that's great. But at the end of the day, my applications and your applications need to survive the disruptions, right? And then even if you created one of those, that there is an automation system nightmare, depending on the type of application, depending on the type of infrastructure that you're working on. So that's where, is there an easy solution? and innovation comes in, and that's where CodeShip actually engaged with us in terms of highlighting this innovation across their customer base. And we come in here and say, yes, there is an easier and a robust and perhaps a lower cost. And I don't want to highlight that one, as you know, but it is much lower than what you would expect in terms of putting together, and compared to the disruptions and the bad reputation or the loss of revenue type of situation, our solution could actually potentially help a lot. And you can very easily get started. The solution is available on the AWS Marketplace, Google Marketplace as well, and then part of the Red Hat Container Catalog. So we made it easier to get started and consume, similar to CodeShip. So the process is very simple: 1, 2, 3, 4. So the 1, 2, 3, 4 steps are very easy to get started. You put in your cloud access point, and we discover all the infrastructure necessary with respect to your application where they are running. And you can roughly describe your assembly structures, click, and put a policy around it. Then we take care of the rest, meaning that an automated application environment time machine is created for you, right? And that is based on your timeline, or could trigger the time machine copies based on your check-ins as well. So you could basically just make a copy just before deploying that large, perhaps disruptive deployment, right? You want to be confident about it. And you don't want to just do a backup of it, because the backup will only help you with respect to a traditional backup. That can continue to happen. That's not a problem. But how do you really kind of, if something were to happen, I have to borrow some time. SREs cannot just expect to magically, press bunch of PagerDuty or Slack buttons and get the job done. It's really, really hard when it breaks. Then if you provided a single click rollback capability, that's one of the great functionality that we have, or a failover. You don't want to actually disturb the existing production environment as is in one of the regions. I want to just borrow some time. I can lose 1 or 2 buckets or something like that, but I should be able to kind of get some of the data that customers are losing right now. If that's the case, you could actually recover in another region as well. So the RTOs need to be really, really compelling in this case. So in essence, you could pretty much integrate with any of your DevOps tool set. Integrate with Jenkins CI/CD or any other CI/CD pipelines, one-liner, and you have your production environment. It automatically builds the application environment time machine, and then you have all the flexibility to get your application resiliency the way you wanted it. Much better than what it used to be. And with that, we can actually provide 3 levels of resiliency. And of course, there are some caveats here. Within the same cloud provider, you can move between, within the region, not a problem. Between 2 zones, if you have not set up, kind of an auto scaling between 2 zones, maybe this is a great way to get started, to give you a zonal level within the region you can protect. And then between the region, obviously, we can retain all the metadata, all of that, and recreate all the infrastructure completely from scratch, except the cases where the data copies need to be made, and we manage that as well. And you achieve level 2 resiliency. In the cases where you want to switch to another cloud provider completely, and this is applicable only for the stateless containers for now. So we manage the Kubernetes capabilities in the backend to give you the capability to switch to another cloud provider of Kubernetes service on the side, and then you can actually connect back to your data infrastructure, a copy of the data infrastructure, if you will, to make sure that your applications actually come up. So we have that flexibility in the same platform. It's very easy to consume and actually with the click of a button. So you can get started today in both the marketplaces. And this is what we are. Appranix is a proven, easy to get started solution, and we provide continuous application resiliency that can be integrated into your pipelines. We are a secure SaaS provider with a 99.9% SLA, and we need to be confident about that we will end up paying penalties to our customers. So we operate at 99.95. Sometimes we push it to 99.99. Even though we operate on some of the well-known cloud provider out there. And we have been recognized by Enterprise Management Associates as one of the top 3 management platforms. So let me stop there. If there are questions, please do not hesitate to kind of type it in. And what I'm going to do is that right at the half-an-hour time, I'm going to dive into a demo with a real code, with a real recovery, all of that good stuff. You know, PowerPoint is great. It's great for me, but you know, so for some people it's PowerPoint to death. But you know, I hope I gave you a conceptual understanding of continuous application resilience. You know, CI, CD, and now CR. Questions, you know, Max. Hopefully, you know, you're able to manage that situation if questions are coming in. If there are questions, you know, you can interrupt me so that I can answer. Otherwise, I assume that we can go ahead and do the demo.
We have a few, but I think that we can cover them after the demo for sure.
Sounds very good, Max. Thank you. All right. So what we are going to do is to chain the code, disrupt, kind of simulate the disruption, if you will, and then let's see if we can recover it. I'm going to switch over to, let's say, 7 different tabs. This is scary to even start with, but I will start with the code. So here is the code, and CodeShip actually builds that code with a click of a button. I don't have to even click that button. It automatically takes care of it. We built the pipeline. The application is actually a very nice application, meaning that you can actually go and buy broken pieces of socks. You know, I cannot seriously imagine paying $99 for this one, but you know, this particular shop is actually real, by the way. It is a sock shop in the UK, and they were kind enough to open source their distributed application to the open source community, and everyone uses it. We customize it. You know, thanks to VWorks, they actually put that kind of a nice buttoned up version of that, and then we modified that as well to our demos. So it's a very distributed application. You can go ahead and buy any type of socks. Of course, I cannot ship them to you. I don't have that facility. You know, I don't have a Prime or anything, but they are nice to kind of look at. And then, you know, the site is real. And you know, the old days of website is, oh, a bunch of catalogs they are running, but that is not the case with this application. This is a very distributed, dynamic application running on GKE, right? So this application, as you can see, the component-wise is too many to talk about you know, 50 different container nodes. What we'll do is that we'll just kind of focus on one particular namespace, in this particular case, sock shop. I have to actually switch and then switch back just to give you an idea. So this set of parts, of course, there will be multiple services at the back end. You can see these are front-end services that are being managed GKE level, and then there are external services. So we are going to combine set of services running on the containers on Kubernetes, particularly GKE. And then there is an external service for catalog DB. That's an external service running. And that external service actually runs on Cloud SQL. So that is a managed MySQL database instance running on a Google platform. So here it is. It's a single instance that's running there. And in the back end, you can see the databases. And the database is one of the databases, and multiple databases. One of the databases is SocksDB. That is the database that we are using in the backend for this application. And GKE, and if you go to the Kubernetes engine, a bunch of clusters we have, but one of the clusters is the GKE cluster, Eastern cluster. And for the demo purposes, I'm going to switch the application over to the West Coast, to the Central US. So let's look at the cluster here that runs all the services for the stocks shop application. You can see a bunch of these services are running in the backend, and a bunch of our components as well running as well. So all these are fine and dandy. That's great. So what we are going to do is to kind of knowingly disrupt this application. And in the backend, you know, you can get started with Appranix here. So you log in. I separated the container part and the Cloud SQL part as a separate assembly, so you can go back and forth. So in 2 different tabs. So that is the container part, and this is the Cloud SQL part. So to start with, you log in, get credentials, You can pretty much configure your cluster. It's very easy to do. Give the name, cluster selection. It automatically, we give you a curl command, cut and paste in your shell. It takes care of everything. You get your clusters, configured in no time. So we automatically just, get all the metadata. SockShop is one of the namespaces that we get. And then put in assembly, you could actually put a policy. You can protect again. So to speak, the backup is already built in, right? You don't have to worry about that because unless we kind of backed up, how can we recover? How can we give you that recovery capabilities or failover capability? So you can have different types of policies. I will walk over that one as well. So you apply the policy and you apply the protection plan, and then protection plan takes care of based on your policy, right? And it builds the timeline automatically. So this is the time machine that I'm talking about. When you say time machine, don't imagine it's too complicated or anything. It's very simple, easy to use approach in terms of going back in time. So you can just go back in time, click a button to recover. So I will demonstrate that at that, after disturbing the application. And Cloud SQL is a very similar one. You configure your cloud configurations, and you can configure AWS, Google. We can get one of the any regions for that matter. And we already configured the Cloud SQL, so it's discovered completely. And you have an assembly that's called SockShop managed dev. That is the one that is running in the Cloud SQL on Google in this particular region, Council Bluffs. So that is completely automatically discovered. You don't have to worry about in terms of Google changing from Gen 2 to Gen 3. They are moving to Gen 3 pretty soon. All of that is taken care of. So cloud assemblies are ready to go. Now, from application perspective, the application is protected with a protection plan here. And that protection plan has an external service. That external service is this SockShop testing service that provides the data infrastructure. So you can combine the entire stack. That's it. That's all you do. And what we are going to do is to change this application for now. So as you had seen, this SockShop is great. It's working, and I can go and buy the socks. But wait a minute, literally. So I'm going to just introduce knowingly simple change. So a simple change. It's committed. GitHub is great. I love it. So guess what? You go here, and I didn't do anything because the pipeline is already set up. It's already running. So the simple change is being run in terms of running the unit test, all of that necessary. And a CodeShip takes care of all of this. Very simple UI. In the backend, everything is integrated. So unit tests are run. The images from the latest container will be automatically pushed into GCR, Google Container Registry, that is GCR. And then we will automatically initiate the resilience. So if you think about what I'm referring to is basically this component where this process is happening, CI, and the CD is happening. And then third step is the CR that's happening right here. Initializing Appranix application resilience will start in a second. And once that process is started, I will show you exactly how that process is initiated right here in the activity log. That protection automatically starts. So an on-demand backup of your container environment is initiated, right? Not only that, that is fast. Great, thank you, because it's not a big change. So incremental, everything is completely incremental. So don't worry about kind of capturing huge amount of data, nothing like that. It's all incremental metadatas and also incremental copies of your databases for your applications where it demands. So if you're not changing much, only 0 KBs will be kind of recorded in the database as well. Whereas in this particular case, the Cloud SQL database will be automatically initiated with a backup. But if you go to, so it's working here. The infrastructure backups are happening automatically. So the on-demand backups are automatically created for you, right? You don't have to do anything except just plugging in few initial credentials, the backup is happening. So backup is done, and it will get back in terms of, we have some more things to kind of finish up in terms of putting the final details around the version management between Cloud SQL and your application stack. So we automatically take care of that one. That way, with that particular check-in here, all the deployment is complete, which means that we captured your environment copy just before the application is deployed. You know what? The reason for that is now, go back to the initial page of the application. The application, unfortunately, is dead, useless. Right? I wanted to buy that application, and now I love the socks. One or two socks that I thought I could take it, but unfortunately, I cannot even see the images. I mean, I'm at this time I'm losing business. I'm losing my reputation as well. I think about on a Prime Day. Maybe Amazon is a wrong example. We could take any example because they can run in multiple regions and they can bring it up. Even the performance slowdown is a problem nowadays, right? So now what we do, it's a problem that we can actually address. So what we are going to do is to go back in time, in the timeline, and before that, we took a copy. So what we are going to do is to just recover that particular copy from that particular time. So we are going to select, not only that, we are going to actually use a central US cluster, okay? Because I don't know what's happening. I don't want to disturb my production instance. I'm going to just deploy it, and I'm going to include a copy of the Cloud SQL with the real world data, with everything from that external service. I'm going to just click a button. That's all there is to it. So I'm going to just, already start. I shouldn't have refreshed. So that part already started here. So once that part is initialized, you can see the backend, Cloud SQL instance will also be recovered, and that recovery will also start immediately right after the backup is done. So here, this is the part that sometimes I get into when I kind of mix both the data here. So the recovery logs will also get started here. So you can see all of that is automatically kind of taken care of for you. And in the back end, the recovery will automatically start. And here, a copy of your Cloud SQL instance has been created here, right? And that copy comes from a production environment. And that's automatically, there are no backups, by the way. There is nothing here. This is a new instance, right? And that new instance is being created automatically, and the exact size of that instance, all of that is same, including the data, just before the application went down. Right? That the pipeline gives you the detail in terms of what it is. This is the point where we took the copy, and then here is the GK environment that actually deployed with a new code, and we get the copy right here in terms of taking care of the sizes of the Cloud SQL, the complexity of the Cloud SQL. You don't have to know any detail with respect to how it is handled, how the APIs are, what are the details between Gen 2 versus Gen 1 Cloud SQL, and how many vCPUs, what is my memory that I used to run at that particular point in time. Oh, is the storage sufficient for this? What is the command? And by the way, can I call data certified Google administrator? There are two different, professional certifications available, one for compute, another for data infrastructure. So now we have to combine these two guys together if they are certified to figure out where the situation is. And then you will have to really think about the connections between your recovered instance as well as your application. Now, not only that, you will have to really think about your containers running in a different region. So Kubernetes engine clusters are running in 3 different clusters we're running. So we actually used this particular one in this particular case. Now you can see all those containers, services, and all of that have been deployed here, and they've been automatically If you wait a little longer, these pods will automatically spin up, increase in terms of size and so on, so that they are back to where they used to be in their primary cluster, which we didn't disturb, because what if this situation is very simple to address, and then we only work too hard to kind of recreate that infrastructure? Maybe we wasted infrastructure as well. So in that case, keep that aside. You can recover your application at that particular fail point in time. You can retain your reputation. Your SLOs are intact, more or less. And as long as you haven't signed too much bad SLA, you could be well within your SLA. You may not have to pay the penalty and so on. So all of that is great, and we were able to achieve all of that with a single click. And that single click, it takes care of the deployment. Some of the things that we can control, some things we cannot, meaning that we orchestrate all of the necessary steps, make sure that everything is intact, and we'll wait for the steps to complete as well. But sometimes, the service providers run their own services at a different pace. So some are really, really quick, some are slower, and sometimes, depending on the workload, they might slow down the recovery and so on. And also, we haven't thrown in a larger instance. Typically, for the demo purposes, we don't throw in a large instance. It's a very small 1 VCP instance, and it is actually, high CPU utilization. So that is also taking a little bit of time. We should have thrown in a better instance to recover quickly. So as you can see, all these situations, you will have to manually go through all these processes to understand what's happening in terms of your application. If you are really bringing in multiple parties to the application here, and those components are too many. So, every one of these components might have, let's choose a better one. Component might have a different application developer, right? And you'll have to identify that particular developer. The PagerDuty type of services will actually help. And if you are able to really gather all the information through the logs, maybe you are able to identify those logs as well. But in most of the situations, it's really, really difficult to identify. By looking at this particular nice icon, how the hell do I know which developer, from an SRE perspective, right? How do I know I can bring up that particular person and connect all the dots together to resolve this particular situation in time, so that I can recover my application really quickly. So recovery in progress, it takes about 10 minutes. So I'm trying to explain all other aspects of it. I should have warned you at the beginning. It takes about 8 to 10 minutes, depending on the time, to recover the data infrastructure of this application. The front-end stateless component of the application is really, really fast. As you can see, the GKE part even failed over really, really quick, because we are able to manage both the containers aspect as well as the configuration of all the clusters in the backend. Those are all quick. So the newer infrastructures like Kubernetes are in a way easier to handle, but the older infrastructure that are running on VMs, they are a little more, you have to have a little more patience with them. And some services are quick, some services are bad. And those of you who have really worked on the database side would understand the complexity associated with kind of recovering the entire databases with a click of a button, right? That's what is being done here, and without knowing any of the time frame. So if you think about it, the timeline, we could go back in time, anytime here for that matter. On-demand copies can be recovered. So this is the time machine that I'm talking about. You can pretty much get into any of these timelines, and you can actually recover at that particular point in time. Maybe, Max, we could answer some other question, because I'm also looking at the clock. And while answering, perhaps the data recovery is done and the applications will be back.
Sure. So we have a few questions that are all somewhat similar. I'm going to kind of combine them into one. Okay. You mentioned AWS, Google Kubernetes Engine. What about a tool like DigitalOcean or any other tools? What would you integrate with or not integrate with? How can people find out?
Sure. So today, DigitalOcean as a plain infrastructure as provider, meaning compute, is not supported. But if you're signing up for DigitalOcean Kubernetes service, we can protect that set of applications running on the Kubernetes service. So as long as it is Kubernetes, we support that. The data infrastructure within DigitalOcean is not supported because we have to really focus on some of the providers that are out there. So if your Kubernetes running on DigitalOcean, we can actually help you kind of recover them on GKE or AKS or EKS on the AWS side.
All right, great. When starting with Appranix, would you recommend that someone just goes right to your website and gets started? Do you recommend they already have specific tools? And I know we kind of just covered this, but do you recommend they already have specific tools in place? Where do you feel the starting point is?
The starting point is actually, it's better to get started if you're a Google or an AWS customer. It's very easy to get started from here. So if you go to AWS Marketplace or a Google Marketplace, it's right there, and it's well integrated. You can pretty much click and go, and it's a subscribe button right here. That's it. Once you subscribe, you are in. You create your account. By the way, you get some credit as well for 14 days, so you can experiment with our platform. For those of you who do not operate on cloud platforms, but you can pretty much sign up through us. Just send an email. We'll create an account for you, or we are going to open up to public pretty soon because we wanted to basically go through the billing aspect. Wanted to be taken care of, so we go through cloud providers at the moment. But you can very easily get started with an email.
All right, great. Before I continue, just to let everyone know, I did fail to mention this earlier, a very short survey will pop up at the end of this, just asking basically what you'd like to learn more about in the future. So at the very end, if you wouldn't mind being able to just take that in for a minute, that'd be great. All right, so let's move on.
Excellent. So let's see if the recovery is done. The recovery is complete. That's great. So we are going to look at CPS and see the recovery is complete with a new instance. What we are going to do is I'm going to use a simple kind of switch of the DNS, because we need to switch the DNS a little bit, because sometimes switching the DNS is an issue, because now you have to really get the permission. So in our AWS product, we actually get the permission, ask you to type to kind of switch over. In this particular case, we give you maybe a script, you can add that in your, we'll simplify it, but you can very easily customize it to your requirement, and it's going to simply switch over the DNS of the Cloud SQL here. Once that is done, the DNS cache needs to be kind of, it's about 30 seconds to get rid of the cache, and the application will be up and running. So let's see if the application is already kind of getting there or not. Should be ready to go in a second. So you can see the entire process is very, very kind of smooth in terms of achieving that continuous resilience without doing much, except initially setting up some of the pipeline, as well as setting up the discovery of your initial assemblies. That's about it. And those are all, again, automated because we don't know all your environments, so we cannot pretty much kind of put an assembly automatically. But that would be the easiest thing to kind of assemble. And once the assembly is done, the application will show up just like this, and you'll get the time machine. So it should be done in a second. All right, that's done. So what we are going to do is to refresh this application. Great. So now, while talking about, let's say 12, actually 15, so 12 minutes, I was able to recover your application, right? The entire application stack running on GKE with a new copy of the application of the infrastructure. I didn't disturb the production instance of your database. This is a new instance, and the production environment is not disturbed. So this is a new cluster running in a different region, all of that. Instead of the East Coast, we are running on the central US, right? And this may be running, the cluster may be running, your application may not be, right? That was the situation before. So that's about it. And if there are any more questions, please let us know, both on the CodeShip side as well as Appranix. We are available to answer any of the questions that you might have. So thank you very much. Finally, are there any more questions? If there are questions, then we would love to answer. Otherwise, we actually conclude this presentation.
I'd like to go over one more that's come up, and this can be for yourself or for Joe, whoever wants to take this. But you were talking about how Appranix works with any CI/CD solution. So what do we feel really sets CodeShip apart for this partnership?
Probably I can jump in. I think Joe may be on mute or something. So what we see is that industry is here. Clearly, since CloudBees started, Jenkins pretty much revolutionized the CI part, and a lot of other companies started as well. Then the CD came along. Now, a lot more plays with respect to CD, because it's all driven by the need for deploying applications in a smaller chunks and faster as well. So there's enough complexity in terms of CD. But that is just the beginning of the problem, because now the issue is a lot of CD activities happening into staging or test dev environments, because you can check in so many times a day, but nothing is it's very difficult to convince your SRE to go and deploy your wonderful code, knowing that it could actually bring down the application. Because what is the guarantee? There is no guarantee. So that is where CR actually is really, really helpful, because no problem, guys, go ahead, do it. Yeah, at least you can actually start doing this activity in the staging environment. You can actually, instead of production, you can do a CR at this level, so that you can make copies and recover and then check it out before rolling into production. And that too, you can roll out into smaller chunks of your application. So the combination from our point of view is really, really powerful. I think we are the first one in the industry. The combination of CodeShip and Appranix push the boundary to kind of brought the entire DevOps tree of closure, if you will. There may be DevSecOps and other things, but that are happening anyway. But we kind of close that loop so that we enabled the application deployments to be sooner. Joe, anything more to add?
I think that's a great summary, and maybe just to add on that a little bit, I think one of the things that a hosted service, a SaaS-based CI/CD service like CodeShip brings, is that it sort of simplifies that DevOps tool chain a little bit. So at least like your CI/CD stuff isn't also wrapped into other systems that like we've been discussing here today. Like there's all kinds of disruptions and failures that can happen. So maybe having, a little bit of that workload distributed to another service is helpful for your particular configuration and use case.
And by the way, Appranix doesn't move any of the infrastructure from it's all managed on the cloud, your own account, everything. We simply come in as a CR provider and manage everything. So we don't take any of your data out, none of that. Everything is managed within your own accounts by using your own services that you buy from Google and Amazon and so on. So everything stays within your account. We simply come in and make sure that you achieve the continuous resilience.
All right. We are at the top of the hour. There's a few more questions. I'm going to make sure they get answered offline. We do have some more good ones too. In the meantime, I don't want to take up anyone's time. You did commit to just 1 hour after all. Before we go, Govind, Joe, anything you would like to say?
So thank you very much. Really appreciate your patience in terms of listening to us. This is a new concept. We might have pushed a lot of data, the information to your brains, but the process is very simple: CI, CD, and CR. So we are pretty much helping the final frontier of the DevOps pipelines. The SRE should be happy. All
right. Thank you everyone for watching. Thank you, Govind, for participating in this, talking about Appranix. That survey is about to pop up for everyone, and we look forward to talking to you all again real soon.
Wonderful. Thank you, guys.